All right, class. So today's lecture is going to be broken up into three components. The first component is I'm going to introduce you to matrices. The second component of the lecture is I'm going to show you how to do a matrix problem in Excel, which we've actually kind of already done, so it should just be a review. And then we're going to do the same problem using Python. So let's start out with that very first one is, what is a matrice? Well, so a matrice is a multi-dimensional array. It's a bin to store numbers in. And so typically you would see a matrix written out something like this. Okay, I just had a slight error with my pen there. So a matrix would be something, let's look at a simple 2x2 matrix. It would look something like this. So all matrices are made up of two things. One are rows and the other are columns. And so basically when you talk about a matrix, you would talk about the number of rows times the number of columns. So in this case, this is what we would call a 2x2 matrix. And it has two rows and two columns. This would be what we'd call a 3x1 matrix, because it has 3 rows, 1 column. So the row number always comes first. Now there's a ton of stuff that we can do with matrices. Matrices and linear algebra is kind of the foundation of a lot of machine learning and higher level mathematics that we can do within our data analytics. But we're going to kind of keep it simple today, and we're just going to use it for what we're going to call dot products, which is also matrix multiplication. So let's go and let's take a look at, I'm just going to give you an example of how you would use a matrix. It's not going to go into how it works. I'm assuming you're going to hit that in your math class. But let's say that we have a system of equations like 3x plus 2y minus 5z equals 12, 5x minus 1y plus 7z equals 18, and then 10x plus 3y plus 8z equals 25. Now this, we have a system of equations. We have 3 unknowns, but we have 3 equations. So if we have 3 equations, 3 unknowns, we can solve this using various simultaneous solving equations. And probably the one that you're most familiar with from high school is a bunch of substitutions into one equation and then back work the 3. Well, this is one of the places where matrices and linear algebra really excel, because I can sit there and I can make my coefficient matrix, and then I would multiply it by my matrices of my variables, and that would equal my solutions matrix. So what would this be is, we would have a 3x3 matrix of all my coefficients. So we would write that out: 3, 2, -5, 5, -1, 7, 10, 3, 8. I would multiply that by my coefficients, and that's all going to equal my answer: 12, 18, 25. So this kind of might look weird at first glance, but this really comes down to how matrices multiply. And so the way that is you take the row and you multiply it by the column to get the answer. And so this is why I have a 3x3 matrix here, and then I have a 3x1 matrix here. These inner numbers have to be the same, because if they're not, you're not going to be able to do the multiplication on them. So what do? I take 3, multiply it by x. I take the second number, these are called elements. I take the element in row 1, column 2, and I multiply it by the element in this one of row 2 in column 1, and then I take the third one, multiply it there, and then I add them together. So what I end up with is 3x plus 2y minus 5z equals 12. And then 5x minus 1y plus 7z equals 18. And then 10x, 3y, 8z is equal to 25. Now that's the way that we set this up. Now, how would we use that to solve? Once again, I'm not really going to go into this. I'm going to leave this to your math class, but it involves doing the inverse of the matrices. So if this coefficient matrix, let's call that A, the XYZ matrix, we'll call that X, and the determinants over here, the answers, we'll call B. And so what you end up doing is we multiply both sides by the inverse of A. The inverse of A times A gives us something that's called the identity matrix, which is just a matrix with ones down the row. And so there's just ones that go down the row. In fact, let's just draw what a 3 by 3 identity matrix here would look something like this. And so if you think back to, because we're going to multiply it by x, if you think about it, that's going to end up being x, 0, 0, and then you go to the next row, 0, the x, 1 for y, 0 for c, and then 0, 0, 1. So you're going to end up with just that x, y, z. And so that stuff is all going to equal b times the inverse of a. You do the matrix multiplication out there, and that gives you what your x vector is, so those answers to that. And so that's one of the things that we can play around with matrices. And once again, there's a lot to do with it. I am sure that you're going to see quite a bit of it as you go along. Very big deal for doing coding and whatnot. And we do a lot of this stuff in Excel, except in Excel, the matrices are all called arrays. And we have dealt with those because we've done different functions that are using arrays within the context of Excel. And so we are going to do one of those here, and then we'll do it again in Python. So matrices are a great thing. There's a lot of stuff that we can do with them, and all of them can be done in Python. They are going to be in the NumPy library. So NumPy, you could call it NumPy, I guess, but the NumPy takes everything and sets Python up in such a way that we can do matrix algebra with it. In fact, we've already used NumPy before because we have used it when we did our graphing, because pandas, which we use for our graphing, and all of our data importation is built right on the back of NumPy. All right, so the important thing to know here is matrices are a mathematical modeling construct that we can do different things with, and we're going to look at it in an example in Excel. Basically, we're going to use some matrix to calculate out how much money we're spending on chocolate, and then we're going to do it again in Python.